Standard exam, question 1. We have an isosceles triangle and we have to find the value of x. Because it's an isosceles triangle, we also know this angle here has to be the same, so it's 34 degrees. All the angles in a triangle add up to 180, which means that x will equal 180 minus 34 minus another 34. 34 and 34 are, of course, 68, and 180 minus 68 is 112, right? 112 degrees. 112. We should write it here in the spot they told us to. Perfect. Good job. Oh, question 2. Are they trying to trick us? Look at this. Y times 27 minus y times 77. This is just what we would normally see is 27y minus 77y. And that looks so much more familiar to us, doesn't it? But that's all it means. So what's 27 of anything minus 77 of anything is 50, or negative 50. Negative 50y, that's our answer. There's only one mark for a question, which means you only get the mark for writing the answer. Find the sum of two things here. So we're adding, do we need to write it? 3 squared minus, sum means plus, right? Plus negative is minus 3 squared. Of course, that's going to be 0. If you have anything minus itself, it does become 0. Trick question. Couldn't trick us. Expand the following. Expand. We use the distributive law, and if the x is going to multiply by everything in the brackets, so we get x times 3 is 3x, and x times x squared becomes x cubed. That's our answer. 3x plus x cubed. On to question 5. Gonna buy some ribbon and some fabric. We're told how much. The total cost is an amount. The ribbon costs something per meter. What's the cost of the fabric? All right, so we know that she brought 2.4 meters of ribbon, and we know the cost of the ribbon, so we can find the total. 2.4 meters times 0.85 per meter. Put it in your calculator, and you'll get $2.04. All right, that's how much was spent on the ribbon. What about the fabric? Well, we subtract it from the total. So 33.48 minus our 2.04 is going to equal, again, why wouldn't you use your calculator? $31.44. All right, so that's how much was spent for the fabric, but we want to know the cost per meter. There's 4.8 meters, so take 31.44 and divide it by 4.8, and we will get 6.55. And of course it's dollars, so let's write 6. Oh, we don't need to write the dollar sign. They have got us covered. Question 6. These are the first 5 terms of a sequence. What are the next 2 terms? All right, so we just have to work out what's going on here. Always start by just seeing if you can add or subtract. Oh, well, it's -1, right? And then it's not -1 anymore. What is happening is it's -3. And then what's happening? Oh, it's -5. And then -11. So there's like a pattern here. We're subtracting an odd number that's increasing, which means if I subtract -9, I'll get to 2. That's not right. Yeah, it's right. It's 2. And then what comes after 9? 11, right? The next odd number. We subtract 11 and we'll get -9. -9. Let's take it. Part B. There's a table which shows information about 2 different sequences. Complete the table. We need to find the nth term. So we're saying term n is sum. We need to find what gives us the terms in this table. All right, let's start what we always start with, right, is adding. What do I add? I add 7. Yeah, and then if I do the same, yeah, I can add 7. And then, yeah, it's always adding 7, right? Yes, +7. All right, so each time we're adding 7, so how can we work out a sequence here? This is the first one, this is the second one, this is the third, fourth, and this is the 5th term. So how do I turn the term number into the result? Well, because we're adding 7 each time, we're going to have to multiply the term number n, we'll call it n. We're going by 7, it's going to be 7n. And then 7 times 1 is 7, but how do I get to 4? Well, subtract how do we get to 3? Subtract 4, and that would give it to us. If you're welcome to check it out. 2 times 7 is 14, minus 4 is 10. 3 7s are 21, minus 4 is 17. It's a good way to solve this problem. So what can we say here? The nth term is 7 times n minus 4. And we don't need that little help there anymore. All right, so for sequence B, actually, it's useful to have that, right? And this is the number of the term. 1, 2, 3, 4, 5. We're trying to turn the n number into the number that's getting increasingly larger. So 2 and 9, and you add another 9, you don't get 26. So we're not just adding numbers. Each time it's getting larger and larger. We did learn at some point that one of the things you would like to check if it gets exponentially larger is n squared. And let's write n squared. And so we will get, what's 1 squared is 1, 2 squared is 4, 3 squared is 9. 4 squared is 16, 5 squared is 25. All right, are these new numbers related at all to what we're looking at here? Yes. So just like, by staring at them for a while, it's like, they're pretty close, right? But what happened there was I started multiplying them, I don't know why, by things. And I said, let's do 3 times n squared, and you'll get 3 times 1 is 3, 3 4s are 12, 3 9s are 27. 3 times 16 is 48, and 3 times 25 is 75. And you go, hey, those numbers are just one above all the numbers in the term. And so what we're definitely looking for is 3n squared minus 1. That will work for us. That's a little tricky one to actually find out, but congratulations if you made some progress with that. Question 7 is, without a calculator, work out this fraction. We have to show our working to get the marks for this. So when you have two fractions, we need the denominators the same. How do we get the denominators the same? The lowest common denominator is good, or you could cross multiply. But 9 and 6 both go into 18. So let's take 5 over 9 and multiply it by, not by 2. Yeah, we do. We multiply 9 by 2, so we have to multiply 5 by 2. And we're going to subtract 1 over 6. And to turn 6 into 18, we multiply by 3. So we have to multiply the top by 3. When we're multiplying fractions by 1, 2 over 2 is 1. And 3 over 3 is 1. It doesn't change anything. So we end up getting 2 5s are 10, and 2 9s are 18, and 3 times 1 is 3, and 3 6s are 18. And of course, 10 minus 3 is 7 over 18. You don't subtract the denominators. They're the same, and we just leave them the same. Cadell records the number of hours in a week 8 people spend exercising. Find the median. All right, to find the median, you need the numbers in order from smallest to largest. So let's find the smallest number, 1.5. I like to cross them out and write them above again. So we have 2 and 2. There are 2 2s, so let's write 2, 2. There's a 3 and a 4 and a 4.5 and a 5 and finally an 18. Sitting out there on its own. How many data values do we have? 8. 1, 2, 3, 4, 5, 6, 7, 8. So the middle is halfway between here. This is the middle, right? This is the median, which is also known as Q2. The median is halfway between 3 and 4. And so how do we find halfway between 3 and 4? Well, 3 plus 4 divided by 2 is halfway between 3 and 4. And that's going to be 3.5. I'm sure you knew that it was 3.5 anyway, so well done. Explain why the mean may not be a suitable average to use. Oh, okay, so for the mean, you add everything together and divide by the number of data values, and it kind of gives you a measure of the middle. But this 18 is very different from all the other values. Remember, maybe it's what we would call an outlier. It's sitting out there. It's going to skew the mean away from the bunch of everything else that is there. So let's say let's use the math tech words, right? 18 is an outlier which skews the mean. What do you think? 8. All right, that just means that it pulls the mean away from what would be a good representation of the data. Question 9, 3 triangles, ABC. And the part A says, which of the triangles are congruent with each other? To be congruent, they have to be exactly the same in all possible ways. And if you look at them carefully, you'll notice that in B, the 6 centimeter is not between the 25 and the 60, but in A, it is between the 25 and the 60 degree angles, and in C, it is between the 25 and 60 degree angles. So B is out of the picture, and the 2 triangles which are congruent are A and C. What's the criteria that would support our answer to part A? Well, you know, if 2 angles are the same, then the third angle also has to be the same. If you have a 60 and a 25, that adds up to 85, and so the other angle is going to be 95, and both the other angles are 95 in the triangles. So we have 2 angles and a side. Which criteria uses 2 angles and a side? That would be angle, side angle, which is exactly what it was presented to you as. Question 10 says to calculate the following. Look, it looks like it's getting complicated, and we do have a calculator. Why wouldn't you use your calculator? It's 1 mark, so you only get 1 mark for the answer, and it looks like it's testing whether you can use your calculator. So type 2000 times 1.2 to the power of 3, and we get 3456. Isn't that nice? 3, 4, 5, 6. For the next one, it's a little tricky entering mixed numbers into your calculator. Let's turn the mixed number into an improper fraction. 2 8s are 16 and 1 makes 17. So let's turn 2 and 1/8 into 17 on 8 and then multiply that by 6 over 17. It should stop us from making mistakes. Calculator says that's 3/4. We probably could have worked that out by cancelling the 17s as well. And for the next one, it's got slightly more complicated. 4.5 times the cos of 30 degrees, but all of that is divided by the root of 3, and then we'll subtract 2 from the answer. And we get exactly 1/4. Well, that's crazy. Crazy, but correct. So question 11, there's a graph y equals x minus 3 times x plus b times x plus 2, and it intersects the y-axis at negative 30. What is the value of b? Well, when it intersects the y-axis, we know x is 0. So x is 0, y is negative 30. Why don't we just use those 2 values, put them into the equation, and see what works out? So negative 30 is the y value, is equal to 0 minus 3. Well, 0 minus 3 is negative 3. Multiplied by 0 plus b, well, that's just going to be b. And times 0 plus 2, well, that's just 2. All right, 2 times negative 3 is negative 6. And so we've got negative 6, b is negative 30. All right, b is negative 30 divided by negative 6, just makes it 5. That's a sweet little solution. And when x is greater than 0, the graph crosses the x-axis once. What's the coordinate of this point? Okay, so we know where it crosses the axis because of the roots. The roots come from the factors. These are the factors. So what x value makes the factor 0? Well, for the first one, x is 3. And so when x is 3 and y is 0, we know that is where it crosses the x-axis. Are the other ones positive? No, because b is 5. That means x has to be negative 5. And for the third factor and third root, we have x plus 2. And so x would have to be negative 2. That would be the root for that one. Question 12. All right, that looks a little freaky. We've got x is 3 squared. No, it is 5 squared times 7 times 199 to the 57 when written as the product of its prime factors. Of course, the powers just mean it's 3 times 3 times 5 times 5 times 7 times 199, 199, 199, and that goes on, 57 of them. Right, x divided by 315 as a product of its prime factors. We have to divide that by 315. You know what would be useful? It would be finding the prime factors of 315. That's a step along the path. Let's do it. 315. We're going to do a factor tree to do this. 315, what divides into 315? Well, we know 5 does. It's obvious. But why don't we try something bigger, like 15? I think 3, 5, 7, and 199, right? Other options. Well, let's try. Got a calculator. 315 divided by 15 is 21. I'm going to do that because it'll make my tree nice. 15 and 21. Now it's really easy. 3 5s are 15 and 3 7s are 21, which means that 315 is equal to 3 squared times 5 times 7. So what we have here in this mayhem of craziness is 3 squared times 5 squared times 7 times 199 to the 57 divided by 3 squared times 15 times 17. All right, we can cancel the 3 squared divides by the 3 squared to make 1. That's good because 1 times anything is itself. And 7 divides by 7 to make 1, and that's good. And 5 cancels one of the 5s and leaves the other one there. And what we're left with is 5 times 199 to the 57. Great job. Question 13. The table shows information about the mass of each of 50 children. We don't normally see things like this. What is it saying? The under 20 kilograms, there's no children. Under 22, there's 7. Under 24, there's 23. It's cumulative frequency, so that makes a whole lot of sense. 23 includes 7, but that's good because it's cumulative, and less than 24 also includes less than 22. All right, so this looks fine. We're just going to use the values for the mass and the values for the cumulative frequency and draw a graph. All right, I can't fit it on my screen, so I'm just going to have to do a little bit of scrolling here. What have we got? 20 and 0, 22 and 7. So 20 and 0. Wasn't that nice? 22 has to be halfway. And 7 would have to be at that point, right? That's 7. Let's just check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, there's 10 lines. And there's 10 lines there. And so 20 to 22 is halfway. That's true. I'm going to write 22 there so you all know what I'm talking about. Let's go back, get some more. 24, 23, 28, 35. All right, 24, 23. Oh, I forgot the next one. 20, it was 28, wasn't it? 28 and 35. 28 and 35. 35 is halfway between 40, between 30 and 40. There we go. And I'm sure that's 28, right? Yes, check. We're all good. 32 makes 43. 32 makes 40. 1, 2, 3. So it's getting complicated when you can't fit things on your screen. 36 and 47. 36 and 47. All right. And we've got 42. And by the time we get up to 42, which is halfway between 40 and 44, that would be 42. We're going to get up to the 50, so halfway is here. Right, we've got our dots. We can almost see it all on the screen at once. We need to join those dots with as smooth a curve as we possibly can. Let's just try. Remember, it's not straight lines, it's a curve. So get your artistic ability out and do some freehand. That's close. That's kind of good, I guess. There's got to be another question, right? Use a graph to estimate the 90th percentile. All right, how do we do that again? The 90th percentile, we're going to find 90% of 50 because there's 50 people. So take 0.9, multiply it by 50, and we get 45. Surely that wasn't too hard. So let's go back up to our table and say, where is 45? 45 is here. So we're going to go across to our graph, and we're going to hit the graph at some point. I'm hitting it there. Then we go down, and we're going to find out the mass when we do this magic of coming down the graph. My class did this fairly recently, so I hope everyone got this correct. And I'm going to land right there. That looks like halfway between 32 and 36. What is halfway between 32, 33, 34, 35, 36? 34 kilograms is my answer. And I'm sticking with it. There you go. All right, 136 girls, 144 boys, each measure the distance they can jump in centimeters. The box and whisker plots show the distribution of these distances. All right, so box and whisker, not whisper. We know the lower end is the lowest data value, and the higher end is the higher data value. And the boxes are Q1, Q2, which is the median, and Q3, that's forms the box. The median is, of course, the middle number, or the middle of all of the data. Let's find out what we need to do. We have to, each child who jumps a distance greater than 160 centimeters gets a certificate. Work out an estimate of the total number of children who get a certificate. All right, well, there's 160 centimeters. You know, this is like, the girls are doing better than the boys here in jumping. Look at that. Let's draw a line here at 160. And what we know is half of the girls, right? Because that's half. That's the median. And half of the girls jumped higher than 160. And in the boys, a quarter of the boys jumped higher than 160 centimeters. So the girls are dominating by a long way. All right, so a quarter of the boys, half the girls. Why don't we do that? 136. A half of 136 plus a quarter of 144. It's 144, right? Let's just check. Yes, and that should possibly be our estimate. Grab a calculator. We punch it in, and we will get 104. All right, so that's good. That's our estimate. 104 people, little people, are going to get a certificate. Start printing. Question 15. We have a quadrilateral. Give a geometrical reason why it is a cyclic quadrilateral. Well, what do we know about cyclic quadrilaterals? We know that vertically opposite angles add to 180 degrees. Is it true? 85 and 95 is 100. Yes, 180. 101 and 79 is also 180. That is the reason. How can we say that? Vertically opposite or diagonal? Vertically opposite angles. Or you could say diagonally opposite angles add to 180 degrees. That should do it. Question 16, shade the region indicated in each Venn diagram. Okay, I love these questions. G and H, or G intersecting not H. It's not and H, it's not H. G intersecting not H means it has to be in G. It also has to not be in H. There's only one place where that happens, where we're inside of the G circle, but we can't be inside the H circle. So don't go over that line or you may fail. For the second one, oh, it's got more complicated. All right, we know the second part, we're intersecting L, which means it has to be in the first part, and then it also has to be in the second part. So the answer is definitely going to be in the L circle because it's and, or intersects with L. So what is inside the brackets that could intersect with L? We've got it's J union not K, which means it has to be in J. Let's talk about the union. So J union means you take everything in J and you take everything in not K. Well, everything in not K is everything around the circle, right? Everything else. There it is, but only where it intersects L. So if we have a look at that, and that's what our head visualized, right? We can hopefully get rid of this mess. We're going to end up with we're in J, and we're not in K. And where does this intersect L? Here it is. No, intersect L. Yeah, it does. It's out here as well, right? Because this is not K. Not K. Right, I think I got it. Actually, it was a tricky one. Okay, the Venn diagram shows some information about the number of elements in the sets A, B, C, and the universal set. That's that funny kind of squiggly symbol. Given the following information, complete the Venn diagram. Whoa, the number which is in A intersecting B intersecting C is 1. Ah, well, the intersection of all three is right in the middle. And so what that tells us is there's 1 in there. The number, okay, so the second one looks more complicated. The third one doesn't look as complicated. The number in C, it says, is 42. And we look at C and we go, but there's already some in C. How many are in C? Well, we have 3. 2 plus 1 plus 7 is 3 plus 7, which is 10. So there's already 10 in C, but it says the number in C is 42, which means there has to be another 32 plus 10 makes 42, right? All right, so we've used the first condition and the last condition. What are we missing? We are missing the number which is outside of all the circles, but still inside the universal set. All right, what is the second statement saying here? It's saying the number A union B union C in brackets, and then not that. A union B union C, just to be really clear, there's my A, B, C. If we take the union of all the circles, we're talking about every part of all those circles. So that's the union of A, B, and C, or it's A or B or C. And then if we say not that, well, then we're just talking about what's outside, which is what we're missing. And that has to be 17. So that's our last magic number to put on the diagram. Question 17 says the function of x is x squared. Find the function of -3. Well, that's pretty simple. When you have x is -3, I'm going to write it. The function of -3 is -3 squared. And I put that in brackets so we don't get confused about the minus sign. -3 times -3 is 9. Our answer is 9. And apologies to anyone who may be looking at this, hoping that they want to see the rest of this question. But at this point, my class hasn't covered that material, so it's not on this paper. Question 18, write 0.419 recurring as a fraction in simplest form. Show all your working. Okay, I like these questions. They're kind of fun to do. 0.419, that's the first occurrence of what's recurring, and that's the second occurrence of what's recurring. And so I like to put dashes over them. What we want to do is we want to take the second occurrence and move it so that it's in place of the first occurrence. So why don't we let x equal our number, and we want to multiply it by 100. So let's go 100x is equal to, I moved it over here so I could line up my decimal places. What's it going to be? It's going to be 41919. Okay, of course, this 19 is recurring. Maybe we should have put dots after it just to see. Well, the whole reason we did that is because now we have two numbers and all of the 19s are lined up to infinity and beyond. So we can subtract and that will just all disappear. 100x minus x is equal to 41.919, that's my recurring part, minus 0.419, my recurring part, and I will get 99x is equal to 41 minus 0, 9 minus 4, we're going to end up with 41.5. Divide by 99 and we'll get 41.5 divided by 99. We need to get rid of the decimal place, so multiply by 2, 83 over 198. That does look like it's in simplest form already. If you're not sure, put it in your calculator, see if your calculator will give you a simpler version. It doesn't. So that is my fraction in simplest form. Okay, question 19. Katie picks a number at random from the numbers 2, 3, 5. And then she picks a number at random from the numbers 5, 6, 7, 9. And she adds them together And the answer is even. Find the probability that exactly one of the numbers picked is a 5. Exactly one of the numbers picked is a 5. You know, there's a few tools we can use to help us with this, but like a tree's not going to be that helpful. You know, a two-way table is actually quite helpful. Why don't we create one? 5, 6, 7, 9, 2, 3, and 5. Whoever thought two-way tables would be so useful. Hey, what are we looking for? We're looking for the outcome is even when you add them. They add them and it's even. All right, let's just color in where it's even. We don't actually need the value. 2 plus what makes an even number? Well, 2 plus an even number makes an even number. So that's even. Nice job. And 3 plus what makes an even number? Well, 3, you have to add it to an odd number to get an even number. And so we're going to have here, here, and here the even results. And 5 and 5, all right, 5 is odd as well. So again, it's the same thing. We're adding to odd numbers. All right, these are all the even results. Okay, everyone happy? Everyone's happy. Find the probability that exactly one of the numbers picked is a 5. Exactly one. The two numbers answered is even. All right, so we can't have two 5s, but we can have exactly one 5. All right, which means the 3 and a 5, I'm going to color it in again, double coloring in, extra special. 3 and a 5, that's where one of them is a 5, and not 5, 5, but 5, 7, we can color in, and 5, 9. Okay, so if we're interpreting this question correctly, it's asking us for, out of these results, what's the probability that one, oh, it's such a confusing question. What's the probability that there's only a single 5 in one of the results? And so, well, okay, how many of them have a single 5 is 3. And out of how many results are there? There's 1, 2, 3, 4, 5, 6, 7 out of 7. 3 out of 7. That's what we're sticking with. Question 20. When we have a power outside brackets, the power applies to everything in the brackets. So this is going to equal 81 to the 3 on 4. And when we have a powered term inside, you multiply the powers. Remember that law, the index law? And so we're going to have 16 times 3/4. The 4 will cancel with the 16 to make 4, and we'll get 4 3s are 12, and we have x to the 12. Okay, so all we have to do to simplify fully is work out what this 81 deal is going on over here. The 4, when we have a rational power, the numerator is what we're raising the power to, and the denominator is the root. I don't know, I was having trouble saying this. X to the 12 just gets to stay there. All right, what is the 4th root of 81? It looks like we should know that. 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 is the 4th root of 81. And so this is going to equal 3 cubed x to the power of 12. All right, 3 cubed we know is 27. 3 times 3, 9. 3 9s are 27. X to the 12. We're pretty good. All right, for the next one, we're doing the same thing, but this time it's negative a half. Okay, you know, let's try and do it the simplest way. 1 to the negative a half, it gets distributed in, and it also goes into the y. And remember, we multiply any existing powers or indices, so negative a half times 2 turns into negative 1. Right, when we have negative powers or negative indices, we can make them positive powers or indices by moving them on to the alternate side of the fraction. So the y to the negative 1 can come up to the top and will become y to the positive 1. We don't need to write y to the positive 1. We can just write y. 1 to the negative a half moves to the bottom, becomes 1 to the half. 1 to the half is the square root of 1. And here is where we have to remember we're not in grade 5 anymore. When we do the square root, there are two answers. It could be the positive or negative version of the square root, which means it's going to be positive or negative 1. And then y divided by 1 is just y. Y divided by negative 1 is negative y. There's two answers here. There's y, and it could be a positive or a negative version of y. Question 21 says, there's a solid made by cutting a small cone from a large cone, shown in the diagram. The height of the large cone is 12.5, that's on the diagram. The height of the solid is 5.5 on the diagram. The diameter of the base is 9.2, which means the radius is 4.6, I believe. Work out the volume of the solid. Okay, to find the volume of the solid, they tell us the volume of a cone there as well, in case you forgot. It's a third the volume of a cylinder. To find what we want to do the volume of the large cone and subtract the volume of the small cone, which is on top. To do that, we need the radius and we need the height of the cone. For the large cone, we can find the radius and the height very easily because the height's there and the radius is half of 9.2. I think we already worked that out as 4.6 centimeters. For the radius of the large cone, that's including the invisible part. The small cone, we don't know what the radius is. And we also don't know what the height is. The height's a lot easier to work out because we've got 12.5 and then we just subtract the 5.5. And what will that give us? 12 minus 5 is 7. So the height of the small cone is 7. Middle of the base, right? Center of the circle to the top. How can we find the radius? Well, what we will do is identify that there are similar triangles there. They have the same angle at the top. They both have a right angle in there. And then, of course, that means the other angle has to be the same as well. So using similar triangles, we should be able to find out the missing radius. Let's call it R. R indeed. All right, how do we work with similar triangles again? We do ratio of sides. So we can say the little radius that we're trying to find divided by the equivalent or the corresponding side in the other triangle is equal to another side in the small one, or the side we know is the height, divided by the height in the large one, 12.5, and that will give us the radius of the small. Well, it won't yet, but if we actually work out 7 times 4.6 divided by 12.5, we will get the radius of the little circle, which is the base of the small cone. Okay, so our handy calculator tells us this is going to be 2.576. All right, sorry, we're running into the not to scale. All right, now we have everything we need. We have the radius of the small cone, the height of the small cone, the radius of the large cone, the height of the large cone. We just have to put it together and we're sweet. All right, let's get somewhere where we can actually do some work, write everything down. Okay, what will we do? We'll do large cone. This is so I can scroll and know what I'm working with. The radius is equal to 4.6 and the height is equal to 12.5. The small cone radius is equal to 2.576 and the height is equal to 7. Okay, we're good now. Let's go back to work. Oh, there's not a whole lot of space. Well, it's no problem. What we said was the volume of the large one, the volume of what we're trying to find is the large one, which is a third pi 4.6 squared times the height, which is 12.5, minus a third pi decimal 2.576 squared multiplied by 7. Of course, there are times signs between everything. Just we generally don't need to write them around the pi. Well, if we can use a calculator well, we'll get an answer. All right, so it pays to be familiar with your calculator. I put that into my calculator. I get 288. No, I don't. I get 228. Read it correctly. 0.34093409. We don't have to keep going with the decimals. What does the front of the paper say? It says normally give your answer to 3 significant figures. So 288, look at the next one, it's a 3. So leave it at 288, and there's 3 significant figures. 288 centimeters. I think we're okay. Right. The volume of 2 mathematically similar objects are 56 centimeters cubed and 875 centimeters cubed. The height of the smaller object is 18 centimeters. What's the height of the larger object? We need a scale factor, and I don't think we actually have studied this yet. So is it possible for you to do? It'd be pretty hard for you to do. What we know with 2 objects, let's go OBJ. Object 1, Object 2. We know that if we have a length in object 1A, we multiply it by a scale factor, let's use SF, we will get A, B, C, D, E. Let's just go to E. We could get a length in the other one. Makes sense, right? And if we get another length in the first one, we multiply it by the scale factor. That will equal the EF. The length in the other one. And let's take a third length. Why? Because for volume we need like 3 lengths, right? A cube prism, rectangular prism. By a scale factor is going to equal EFG, because that's how similar objects work. There's a scale factor, you multiply any length in one object. By the scale factor you'll get the length in the other object. Okay, so this is a very rough proof for you. Very rough indeed. So how do we find the volume? We're going to take, let's just say it was a prism. For example, for object 2, it's going to be easy. It will be, the volume will be EFG. Multiply them together, we have the volume. For the first one, actually, let's not do that. Let's do, for the first object, the volume is going to be A, B times C. Yeah, and then for the second one, because E equals A times the scale factor, the volume would be A times the scale factor times B times the scale factor times C times the scale factor, because E equals A times scale factor. B and F equals B times scale factor. So the volume of the large one actually turns out to be ABC, which is the volume of the small one, times the scale factor cubed. All right, so all of that was just to show you, or to say this is the only way you could have worked it out, is that the smaller one obviously will have the smaller volume. The smaller volume, 56, multiplied by the scale factor cubed is going to equal the larger volume. All right, so how do we work out the scale factor? We're going to do the cube root of 875 divided by 56. So that will equal the cube root of 15.625. And if we do the cube root, we'll get 2.5. All right, so the scale factor is 2.5. Notice then that all we have to do to find the height of the larger object is take 18, and because it's a length, multiply it by the scale factor, 2.5, and we get 45. All right, there's my answer, 45. If you worked out that, you get bonus points. All right, last question, 23. So we have a fraction plus a fraction equals 3. Sounds easy, right? But those, how do we add fractions? We need common denominators. How do we get common denominators? We can cross multiply. Okay, that's it. That's the spirit. That's what we're going to do. To cross multiply, of course, we do 4 times, well, we multiply the first fraction by the bottom of the second fraction. 2x minus 5. Actually, let me write it all out to explain it for you. Then we'll do it the faster way. So 2x minus 5 times 4. And of course, we need another 2x minus 5. Of course, we want to multiply by 1, and then x plus 1. And if we multiply those together, we get a common denominator. Notice the two things are multiplied together. And then we're going to add, and for the second one, we already have a 2x minus 5. We're going to multiply it by x plus 1 and x plus 1. And that's awesome. Now they have a common denominator. We can add the numerators and life is good. But notice what happened here. We multiplied the bottom of one by what's on the top of the other. And we got 4 times that, right? And then we multiplied the bottom of the other by what's on the top. Yeah. And we actually multiplied them together as well to get the common denominator. That's how you cross multiply. So that's what we should do. That's the reason why it works. Let's do it. We're going to get 4 times 2x minus 5 plus 2 times x plus 1 all divided by x plus 1 times 2x minus 5, which equals 3. We're almost finished. Yeah, right. Yeah, right, you say. All right, so I don't like a single fraction. I'm going to take the bottom of this fraction up to the other side. We're dividing by that whole thing, so let's take it up and multiply by it. And at the same time, let's expand the numerator a little. Let's do 4 times what's inside and 2 times what's inside. Get rid of the brackets. So 4 times 2 gives me 8x, and 4 times 5 is 20. Good job. And then we've got 2 times x is just 2x, and 2 times 1 is 2. On the other side, we have 3. Remember, we were taking this up. We should really expand these brackets. We'll do it later. X plus 1 and 2x minus 5. Okay, we're going to expand the brackets, but remember, 3 is multiplying by what's happening here. And it's not just multiplying by the first thing that's happening. It's like effectively multiplying by everything that's happening. So either we throw it in to the brackets and then just don't worry about it, or we be really careful and say, you know what, we'll expand and then we'll multiply every term by 3 afterwards. And that's actually what we might do. On the left-hand side, let's simplify this. We get 8x plus 2x, 10x, and 2 minus 20, well, that's negative 18. On the right-hand side, we have a right versus left at the moment. Let's expand this. So we're going to do, of course, the double expansion. X times 2x is 2x squared. X times negative 5 is minus 5x. 1 times 2x is plus 2x. And 1 times minus 5 is still negative 5. The only like terms are the 2x's, of course. We can put them together before we multiply by 3. What do you think? Too bad. We're going to do it anyway. 2 minus 5 is negative 3x minus 5. We're doing so well. Do I have to write this side? Nothing's happening over there. Okay, it gets to get repeated. Is equal to 3 2's are 6. We have 6x squared minus 9x. The 3 is getting distributed minus 15. All right, isn't this good? Now all we have to do is collect like terms. You know, I like my x squared coefficient being positive, so I want to leave it on that side, and I'm going to bring these things over and work with it like that. So when we subtract them, we're going to be left with 0. And on this side, we're going to get, the 6x squared gets to stay there. We get negative 9x minus 10x, negative 19x. Dang. We get minus 18, we take it over, we add 18. Well, that's nicer because we get negative 15 plus 18 is just positive 3. All right, we have a quadratic to solve, and maybe I can do another column so that it can just all stay on the screen. Yeah, let's move up to the top. We're trying to solve this quadratic, which we can't make any simpler than this. We have 6x squared minus 19x plus 3 equals 0. The first thing we should try is by inspection, and we look for, right, the a times the c. So remember, with the quadratic, we have ax squared plus bx plus c, the generic form. of a quadratic. So when I say A, B, and C, that's what I'm talking about. A is 6, B is negative 19, C is 3. So A times C is 18. We're looking for two things that multiply to 18 and add to negative 19. Multiply to 18, positive 18, add to negative 19. And that's negative 18 and negative 1. Negative 18 plus negative 1 is negative 19. No, and negative 18 times negative 1 is positive 18, which is 3 times 6. All right, so we can do a little bit of an expansion here to factorize this and solve it. So let's do 6x squared minus 18x minus 1x plus 3 equals 0. First two terms, take everything out that we can. We'll take a 6 and an x out. That leaves us with the x minus 3. In the second one, we're going to take out negative 1 because then it leaves us with the x minus 3. Brackets have to be the same for this to work. And of course, we can now factorize the x minus 3 out of both terms, and that will leave us with a 6x minus 1. If you multiply two things together and the result is 0, it means either of those things is 0. So if the first bracket is 0, we're going to get, I feel like taking shortcuts, but I'm not going to. 6x minus 1 equals 0, or x minus, that's meant to be a minus, minus 3 equals 0. In other words, that's the easier one, right? X equals 3. And this one, the 1 goes over, and we get 6x equals 1, and divide by 6, x equals 1 on 6. So what do we have to do? Solve it. That's our solution. X is 1 on 6, or x equals 3. I'm going to write it here. Solution. X is equal to 1 on 6, or x equals 3. I just rewrote what I already had. But it's, it's on the same line now, so I feel happier. Well, there you go. Done.